Hey everyone, and welcome to another TidalCycles video. Been slightly more inconsistent than I would like, but yeah, it's been a little zany lately. So so the last video posted, and then the one before that, we were talking about this whole idea of constructing new patterns out of old by treating it as like rotations on a circle. And one of the things I think I wanted to try was a little more of like, so I have this new function since last night that I'm calling iter fast. So it's basically iter list, except that it's got a fast cat in here. So then it's conjoining all the individual permutations, like it's conjoining all the pieces together into one cycle instead of, across multiple cycles. And so that's cool. In that, that's it's going to be kind of like iter. In fact, actually, let's just check something here. So if I were to say iter, I don't know, 4 of iter for fast cat of need a fourth one here. Let's say okay. Let's just try this and listen to it. So that's doing what I'd expect, and so similarly, let's just check and make sure these two will do the same thing, which is iter fast. Oh yeah, and I have these aliases, well, not aliases. I sort of did as primed versions and unprimed versions. The primed versions just have the skip distance, which is like how many your spots you're rotating in the circular permutation at a time, which should allow for some interesting stuff. It's a fixed parameter because that's sort of what makes sense for the permutation, but we'll see. Okay, so if we do this, and it's mad because what's wrong? What did I do? Oh my goodness. Okay. I don't even understand how that type checked, but okay. What? What are you talking? Oh my goodness. Okay. Let's do something silly here. Okay. Notice how it got louder? And we're not hearing two sets of samples at the same time. So these are synced, right? These are doing the exact same thing. It's a nice little check when you're dealing with audio, right? So, okay. So I sort of like iter fast for the fact that it has the skip distance possibility. And it also has the just the convenience of it has an interface more like CAD and FastCAD, right? Where you're just taking a list of things, which I feel like is weirdly more natural as a way of doing it. I mean, like iter is a very like nice general function for chopping up patterns, but like I feel like this is a case where it almost makes more sense to sort of specialize to the fact that we're dealing with lists of things rather than a general like partition and rotate of like arbitrary patterns, you know. Okay, so that's part of what I wanted to show. Let's also do something like okay. So yeah, actually let's just make sure that like these two are still agreeing. Okay, yeah, they're clearly still doing the same thing. Okay, which is good because that's what we want. But obviously, if I were to do something like Interfast 2, well, it'll be different because so that's at least that's something. And I feel like this is getting to but then like one of the other possibilities was generating like much more broad ideas of permutation. So like where you can where each cycle you can rotate right, left, or stay in the center. I'm trying to think about like what the best way of doing that is. And I suppose really the thing that would make sense so this permutes here gives us a list, right? It gives us a list of rotations based off of the skip distance and all of that. Okay. So what what I think might make sense is if we want to have a function that has a type sort of like we want to have like pattern of int to maybe even yeah, I think pattern event to, um, you know, a list of A to a pattern of list of A's. Okay? Like, that's the most general type of what we want here. And basically, so what would that be? I'm just sort of writing the type here, and then I'll sort of roughly write the function. I'll put it in that statement in a second. Sorry about the dry cough. It's been very bad lately. I don't really know why. But yeah, so this is a pattern of ints. And what do we have? We have our normal rot list, which takes, an int, and then does a, takes an int, and then just rotates with this function. Okay. So L, so I think what we want here is this should just be an fmap, right? Should just be fmap of the partial function. So we'll say I2 rot list I of 1 applied to Pn. Okay, well, that type checked. Well, I mean, type checked, compiled, etc. The definition was accepted. And what does it say the type is? It says functor. Oh yeah, I mean, I suppose it's general enough that it's just a functor, not even restricted to pattern, right? And then so then what do we do to get, like, how do we rewrite all of this? If we just have sort of a general thing, it takes these patterns and does rotations on lists. Well, at the end of the day, we need something that will create, so we're going to have a, so what are we likely going to do? We're likely going to have a pattern of list of pattern. Okay. And having to actually just think about this a bit. So that must be okay. So let's say we want to take a we have a thing that generates a pattern of lists of patterns. Okay. And then we can map. Okay. Then, so the next step is the equivalent of iter fast p is going to be something that takes, rather than a skip distance, it's going to take a pattern event. So it's not a fixed pattern. There's something funny about this where it's almost like, okay, just to get like uber nerd here, there's like an aspect of this like patterns of hints that almost feel like choice sequences and like, you know, like Brouwer, like constructive mathematics type of thing, like where you have like these free choice sequences and you deal with like infinite things, and that where it's like, yeah, anyway, sorry. So I don't know why I'm so self-conscious in my own video. It's maybe a little weird. Okay. So what we want is this. And let's, I can never remember. We have, is there just, it's not bind, it's unwrap, I think. Unwrap is the thing that's used in the monadic instance. Pattern of, yeah, I think it's something like that. So I think this is like the main, this is join. This is join for, I said bind earlier. This is join for the pattern monad. Like the basic one that's used is, I believe, unwrap. And like, because unwrap and squeeze join both fit the monad laws. I remember that was like one of the first things I did learning Tidal was like prove that through like some, well, not prove, right? Create evidence as to that fact with, you know, test cases and some calculations. I argued that to Alex. It's weird because it is one of the very first things I did in Tidal. It was just like, oh, what's the monad structure? Because I'm a dork. But yeah, unwrap. So we know that we need an unwrap here. Because that's the only way to take pattern of patterns, right? So we have pattern events, a list of patterns. So it's got to be unwrap of something. And so I think what we need is unwrap of map fmap fastcat, because the inner part is going to be, it's going to be a list inside the pattern, so we have to merge that. Unwrap fmap fastcat of list p pn val, and okay, that function is going to be fully applied. So yeah, we don't need to have the dots. It's going to have type pattern of list of pattern. It's going to take that and it's going to smush that to pattern of pattern. And this takes pattern of pattern and squishes it down. Actually, let's just test something about unwrap that's actually like super bothered me for a while, which is so let's try like a weird structure, because I'm basically I never have good intuition for like what unwrap does with like multiple cycles. let's test something. Okay, so if we say unwrap of, so we need something of type pattern of pattern. So if we do something like unwrap of cat of 0, 1, 2, 0, 2, oh no, 3, 3, 4, okay. And then, okay, so that's going to be, okay, but what we actually need is, I'm trying to create a list of patterns. I'm trying to create a pattern of lists of patterns. It's actually like a weirdly difficult type to easily come up with a non-contrived example of. Yeehaw. Anyway, let's just see if this compiles. Let's see if this compiles, and let's see if it does what I'm hoping it'll do. Because if it doesn't, then heck. Okay. Oh, typo. Okay, that compiled. Okay. So, iter fast p of just the constant pattern 1 should be the same as iter fast. Right? I'm pretty sure. Okay. Let's see if that's true. I'm sorry. I feel like this video just has like chaotic energy. But then again, I am trying to like live coding here in a way that I am like hoping works, but I'm not super sure will work. Okay, what does this do? Let's find out. Let's see if it matches up with this, because they should be the same. Excuse you. Oh. Okay, they're not actually quite lining up. Huh. Like almost. Wait a second. Wait a second. Wait a second. Is that because they're actually not lining up? Or is it because permutes is fixing a starting point while doing it with patterns is not? Oh dear. Okay. Oh dear. Oh, right. If I do... Okay. If I do this, let's see if they line up. Also, if they don't line up, that doesn't necessarily mean this is wrong, per se. But let's see what happens. What am I missing? this is probably something super obvious. I can just feel the energy from the future of people watching this and being like, oh, my goodness. Well, yeah, there's a really obvious issue here. Wait a second. Yeah, okay. Here, let's take out the little bit of variation, and then I think it'll be more obvious what's happening. Anyone in the audience want to tell me? Unfortunately, you can't respond right now because we don't have time travel. Okay. So the problem is that this isn't carrying forward. It's not threading through, right? It's doing this F map. Like, we don't want an F map. We need to fold across the iterations, right? We need to accumulate the changes, not just rotate once, because we're just, it's constant. Do you get what I mean? So, yeah, we're going to introduce a little friend here called fold M. Which is in import control dot monad. Okay, so now fold M. Okay. Here's one of the rough questions. Does fold M work for the pattern monad? Fold M doesn't work for everything. This. Basically, fold'em says, B goes to, and so yeah, let's. So yeah, let's specialize this a little. Okay, so let's say list of A. Let's say int. Wait, what? What? So we have something we want to return. Oh, I was mixing up what the. Oh, wow, okay. So to actually, yeah, we need to find out if. Oh, okay. Here's where I was getting mixed up. Here's where I was getting mixed up, y'all. The question is pattern foldable? Let's find out. And the answer is no. This sort of makes sense. What would it mean to even fold over pattern? What would that even mean? Oh dear. I think we've come across some rather zany questions mathematically. Because, yeah, what I want is to accumulate changes across the data structure using this pattern, where I want to basically take the values out of this and use them again and again and again. That's an interesting one, isn't it? I mean, that's what I want, right? I feel like that would lead to like the really interesting thing. So let's. We've been going for a half hour, so either I'm going to figure this out, or I'm going to call it, and then we'll pick it up in the next video of like hammering home this problem, because this is an interesting one. Because, yeah, what we want to do is fold over want to fold over the values of the pattern. But that's I mean, that as an accumulation that feels kind of ugly. Well, is it? I mean, basically it's integration. Right? Folding over something like this is integrating. Blobbity blob, more or less. I guess one thing I'm trying to figure out is, are foldable things... Does monad or applicative imply foldable on some level? Because then that would make everything like way simpler. I guess part of the problem is that what we need is we want like a left fold, right? We know that. Shoot. Now I'm realizing that there's like an aspect to how patterns work that I've never entirely been comfortable with, and I didn't realize why until hitting this point, right? So I think what I'm going to do is in this video here, upload it with the caveat that we need to figure this out, and then I might like do a thing of like upload it like either offline or silently record myself actually coding and seeing if I can figure out what a good fold over what an accumulation over pattern would even look like. Okay.